Hello there. This is a follow-up video because the first two parts to this, what's become a little series now, was looking at using an algebraic calculator versus an RPN for an ungainly expression, which is this thing here. This is one of the time value of money equations. I did explain it before in the previous ones. Essentially, if you're putting this amount of money into a savings account, or either if you wish to, borrow it, and then you were to pay out a certain amount every second for an entire year until there was until it had either all gone from your own account or from someone else's, then this calculation will tell you how much needs to be paid per second. And it's a bit of a horrible TVM problem, because you've got a massive N. This is like more than 30 million. This is the periodic interest rate, so this is the interest rate for each payment, which is your yearly interest rate divided by N. So this is a tiny number. You can see in the formula that you need to add a tiny number to 1, and that becomes a real issue with loss of information. If you imagine you've got a tiny I, you can show that in scientific notation on a calculator, and they have no problems with computing with scientific notation. But you add 1 to it, and then what you're going to do is 1.0000, etc. And then you're putting it to the power of like minus 30 something million, so it's testing your algorithms there. So yeah, not only is this a tricky problem to actually type into your calculator, it's also a bit of a tricky problem for your calculator to solve. So we're having this discussion on one of the threads about if you're into finance, do you work out this from first principles, use any scientific calculator, type this in? Obviously very good and useful for your understanding of what you're doing, but I wanted to see how much less accurate it was than using the built-in time value of money equation. So I tested all of the scientifics I could get my hand on, and some of the financial calculators, and I did the financial calculators using both the formula and also the TVM solver. And in theory, the TVM solver should be optimized for this kind of problem. So we got some results here. I won't go into how I calculated these. It's a little bit convoluted because you need to use a multiple precision library, and then I've spent a while trying to figure out what accuracy really means. Most places, in science, they don't tend to deal with accuracy so much. They tend to do with error, the absolute error or the relative error. That's a really difficult thing to visualize, so I've simply taken the error and taken the minus log 10 of that, which gives you an idea. I mean, the number is roughly the number of digits of precision that you get, ballpark. Anyway, these are the results. Sorry, it's raining here, but I'm going to just get this video done. I will get closer to the mic. God, it's really chucking it down. Right, let's try and stop this getting so wet. Yeah, so these are the results. They're really interesting, actually. I'll show them to you in a graph as well. You've got a bunch of Casios here. Casio 83WA. I've got them to hand, so we got that one there. That's the W series. We got another W series, 115W. These are actually these are sort of 12-digit precision calculators, even though they advertise them as 10-digit. MS series, which was just after that, and they essentially give all the same results. Oh God, it's really chucking it down. Hopefully you can still hear me. Getting a little bit wet. Yeah, so you're basically getting the same accuracy, which is 5.5. That's what you get for 12 digits, essentially, by the looks of it. If you look down here, if you look at the HP12C, now essentially this one here. This is the famous financial calculator. It's only got 10-digit precision, but its TVM is highly optimized. So if you do it using the formula, you only get a 3.3. But if you do it using the TVM solver, you get a pretty stonking 12.3, which actually beats a lot of the other calculators here. Now, going back in time, you've got the TI BA2, which is this one here. This is a pretty old calculator, but would have competed with the 12C at the time. Interestingly, this has got no optimization at all. 3.7 using the formula, 3.7 using the TVM solver. So that's a bit disappointing, actually. Now, up next are the 12C Platinum and the 17B2. So this is your 17B2 here. And that's a Saturn era calculator. And then your HP 12C Platinum, I think, has got similar architecture to the Saturn series, and you can see their results are almost identical. 5.5 using the formula, and 14.8 using the TVM solver, so really excessive amounts of precision there. If we go up here, you can see that the Casio FX992S, this was advertised as a 12-digit calculator back in the day. This is a really old one. Can't quite remember the year it came out off the top of my head, but pretty early. It's actually 14 digits, and it's similar in fact to the modern Sharp ELW506, which is a really fantastic calculator. So these are essentially 14-digit calculators. They return 6.6 using the formula. Casio then looked like they worked on their underlying precision. You got your FX85 GTX, which is sort of the EX series, same as your 991 EX, which is like their best scientific calculator, and they increase the precision there. I think it's to about 14, 15, I think. So pretty good, 7.6 there. And then you got your CW series. So this is the GT85 GT CW, which is the same as the same calculator platform as the 991 CW, and they up to even more, to 23 digits. So using the formula on its own, it's getting 11.3, and that's really impressive kind of precision there. Right at the top, we've got Plus 42 and we've got the DM42. They both run on the same system, which is essentially a quad precision Intel decimal library. So unsurprisingly, they get exactly the same 27.3, really high score for the precision in terms of formula. Both of them improve on that. This is my TVM solver here, 34.8, and the Plus 42 TVM solver does a bit better at 35.9, which is quite interesting. Now the HP 12 Rogue is a Rogue 12C, which we think was made around 2023, maybe 2024. That has got 16-digit precision, and so it pulls in a very reasonable score on the formula of 9.2. But like the TI BA2 from the 80s, it shows no improvement with the TVM solver. It's pretty bad. So if you have a look, I can plot that out as a graph. Got here. So at the bottom here in blue, we've got the TI BA2, and that's the TVM solver, and the formula, they're exactly the same height. We've got a whole series of Casios here. We've got the Sharp and the old Casio 992S, which did very well for its year. You got the GTX, which is your EX kind of series. You got your HP 12C, which shows a big difference between using the formula and then using the TVM solver. So if you've got an HP 12C, you are definitely going to want to use the TVM solver to get reasonable accuracy on these. The Rogue does better because it's got 16 digits of precision, but it doesn't improve on that at all on the TVM solver. Got the TI 83 Plus, which is this one here. This is actually a very good calculator. It's got 14 digits of precision. The TVM solver is very versatile and it's very good. I've shown that before. Again, a really big improvement there with the TVM solver. HP 17B2 B2 and the HP12C Platinum, which I suspect have similar underlying architectures, although people disagree with me about that. Anyway, big difference there, massive improvement using the TVM solver there. RPN 83P, this is an enthusiast project, which basically gives you an RPN calculator on your TI-83 Plus. It's a fantastic project, very, very good, highly recommended. And actually the TVM solver on this is even more optimized than the built-in one. So you can see here it's pushing very, very decent heights there. And then you've got your GTCW here, which has got 23 digits precision, and then you've got your sort of, you know, your 34 digit precision ones, which are much improved, but you can still see how much more of an improvement you get if you optimize your TVM solver. So I noticed a couple of things. So one thing was, just to comment on before I finish this video, one thing was that the Casio seemed to improve over time, but the 992S seemed to be a bit of an exception in that it was very good for its time. So we have a look at that. So we've got year on the bottom here, and then which calculator. Hopefully you can see that okay. We've got the Casio FX 6300G, which is where is that calculator? This one here. This is a really accomplished kind of scientific size graphing calculator, but it does seem to only output 10 digits, and yet it does very well. It does as well as the later 12 digit ones, so I think underlying precision is going to be about the same as these two. But look here at the Casio 992S. This seems to be sort of early 90s, looking at the graph here. So it does very well there, and then they kind of return back to a lower precision later, which seems a bit weird. Then later on they got to the EX series, and they improved the precision, and then even more so for the CW series, basically. Yeah. And then the other thing that I found interesting was basically the number of digits tell you how well you're going to do with the formula approach. That may not be that surprising, but here's a little graph of that. On the bottom we've got precision. Right, got precision here on the bottom, going from 10 to 34. And if you have a look right at the bottom, we've got the HP12C down here. This is the accuracy up here, and you can see basically there's this linear relationship between how many digits of precision you have and how much accuracy you can achieve using the formula. Couple of exceptions. This one here is actually a Casio. That's the label's a little bit unclear. Let me just make it a bit bigger. Yeah, there we go. So this one here is the Casio 6300G. It says it's 10 digit precision, and that's all I can get out of it, but clearly underlying precision is more like a 12 digit precision. Otherwise they track along here. TIBA2 maybe just falling slightly below the line there, which I'm sure Professor Kahan would have something to say about that, but that's actually an 11 digit precision calculator. HP12C Rogue with 16 digits seems to make use of all 16 digits. CW series seems to fall a little bit low, and I have double checked this, so I'm not sure what's going on there exactly, but either way, you know, it has 23 digits of precision, maybe doesn't quite output all of that, and then up here we've got our 34 digits. Anyway, that's it really, and these are all the calculators. So it was kind of interesting. So what can we conclude? I would say that if you want really good precision from a TVM calculation, use a calculator with a good TVM solver on it, but it is important for you to know the formulae as well, even if you don't quite achieve the same levels of accuracy. And then on top of all of that, we're looking at absolute tiny fractions of a decimal point. So, you know, arguably, do you really need all that precision? I don't know, probably not. I'm not a finance person, but I find it interesting. That's all. Cheers, bye.